Good morning, and welcome to this webcast about Windows Server 2012, Upgrading Active Directory, Part 1. My name is Courtney, and I will be the English dubber for this webcast, made by Fabrizio Volpe, Microsoft MVP on Directory Services. This webcast is the first part of a series and is taken from a speech I held during the Windows Professional Conference 2012 in Milan. This is an Italian event organized by OverNet Education and Microsoft. In the agenda, we have an overview of new and updated features, an explanation about Simplified Deployment, a demo about Windows Server 2012 Domain Controller with GUI, an overview of what is new on Install for Media, an introduction to Virtualization-Safe Technology, an overview of rapid deployment and DC cloning, a list of steps for deploying a cloned virtualized domain controller, a demo about DC cloning, new and updated features. In this picture, we can see a list of new or updated features that are important from the Directory Services point of view. During this webcast, and the following ones, we will only talk about a limited number of features: Simplified Deployment, Virtualization-Safe Technology, Rapid Deployment, and Active Directory Platform changes. Active Directory Domain Services (ADDS) deployment in Windows Server 2012 is simpler and faster than previous versions of Windows Server. The ADDS installation process is now built on Windows PowerShell and is integrated with server management. The number of steps required to introduce domain controllers into an existing Active Directory environment is reduced. This makes the process for creating a new Active Directory environment simpler and more efficient. The new ADDS deployment process minimizes the chances of errors that would have otherwise blocked installation. In addition, you can install the ADDS server role binaries, that is, the ADDS server role, on multiple servers at the same time. You can also run the ADDS installation wizard remotely on an individual server. These improvements provide more flexibility for deploying domain controllers that run Windows Server 2012, especially for large-scale global deployments where many domain controllers need to be deployed to offices in different regions. ADDS installation includes the following features: addprep.exe integration into the ADDS installation process. The new ADDS installation is built on Windows PowerShell and can be invoked remotely. The new ADDS installation includes prerequisite validation. Confirmation pages are grouped in a sequence that mirrors the requirements of the most common promotion options, with related options grouped in fewer wizard pages. This provides better context for making installation choices. You can export a Windows PowerShell script that contains all the options that were specified during the graphical installation. Only critical replication occurs before reboot. Demo, DC Upgrade. Using the GUI. Introducing the first Windows Server 2012 domain controller. Greg Jaworski. The first thing we need to do is install Windows Server 2012. There are several new installation options. Also, while we recommend Server Core, you can now move between Core and Full with just a reboot. We also have the new Minimal Server interface, which will give you core GUI components like Server Manager, but no Internet Explorer or Windows Media Player. So if you would rather get started with Full and then move to Server Core or Minimal Server interface, especially on that first domain controller, you can now do that. Add the Active Directory Domain Services role. If you run dcpromo.exe, you will get a message pointing you to go to Server Manager. We will choose Active Directory Domain Services. We can also choose DNS Server at this point as well. If we don't choose this and check the DNS box as in the past, we will install the DNS role as part of that process. After installation completes, we will be prompted to make the server a domain controller. Just like in Windows Server 2008 R2, just installing the role simply copies the bits in the proper location, and it does not make the machine a domain controller. At this point, if you click the link, you will then start the DC promotion wizard. If we don't, for whatever reason, we will be able to do this from Server Manager later. Once you click that link, the Active Directory Domain Services configuration wizard will launch. If there is an issue with the environment that will prevent you from introducing the DC, you will get an error message. Instead of this happening at the end of the wizard, we will be stopped to address this before we can continue. We can now choose to install from media, and we can also choose, if we want, to do initial replication from a specific DC or allow Windows to pick the DC. This process is site aware and will pick a DC in that site if one is available. We can choose paths for our databases, logs, and SYSVOL. Guidance has not changed here, and like any database, we recommend splitting logs and the database on different spindles. You can choose the More About Active Directory paths for additional information. If you have not already prepared the forest domain and the domain controller promotion process, we'll do this for you. For those who prefer that this not be one integrated step, we can still run add prep. You will get the typical summary page of your selections, and then new in Windows Server 2012, we will do a prerequisites check. You can also export all of your selections to a PowerShell script. In Windows Server 2008 R2, we are able to export this to a DC promo unattend file. In Windows Server 2012, this will be a PowerShell script. As was the case in Windows Server 2008 R2, this script will be specific to what you performed. So in this case, this will be adding a domain controller to an existing domain, which is the most common scenario. If you are creating a new domain or forest, then you will have to modify or create a different script. You can see that we have performed a prerequisites check. This is a new feature in Windows Server 2012 that will make you aware of potential issues or concerns before you complete making the server a domain controller. The server will then reboot, and just like in previous versions of Windows, we will now have a domain controller and can do whatever checks your organization deems necessary to ensure that everything is running smoothly. Simplified deployment. What is new? Streamline the deployment process. By integrating preparation and promotion processes and automating prerequisites in between. Minimize odds of deployment failures. By validating environment prerequisites before deployment. Minimize number of touch points. By providing remote capabilities for both preparation and promotion processes. Optimize for common deployment paths. By aligning the configuration wizard to the most common deployment scenarios. Bring consistency with other Windows Server roles deployment experiences. By integrating the full deployment experience with Server Manager. Gain UL consistency by leveraging an enhanced command line experience. By providing a deployment and configuration wizard that is built on top of Windows PowerShell. Install from media. Windows Server 2012 adds 2 additional options to the ntd sutil exe command line tool for the IFM media creation menu. Create full no defrag %. Create IFM media without defragmenting for a full AD DC or an AD LDS instance into folder %. Create SYSVOL full no defrag %. Create IFM media with SYSVOL and without defragmenting for a full AD DC into folder %. Simplified Deployment. Requirements. Windows Server 2012. Target for us must be Windows Server 2003 functional level or greater. Introducing the first Windows Server 2012 DC requires Enterprise Admin and Schema Admin privileges. Subsequent DCs require only domain admin privileges within the target domain. Additional features we will use. DC promotion retry logic. Since Windows 2000, DC Promo has been intolerant of transient network failures caused promotions to fail if the network or helper DC hiccuped. Windows Server 2012 promotion employs an indefinite retry. Indefinite because no sufficiently meaningful set of metrics available from which to assert sufficient progress, so we've deferred the decision of failure to the administrator. If the ADDS installation encounters an error during the critical replication phase, the installation can hang indefinitely. For example, if networking errors prevent critical replication from completing, the installation will not proceed. If you are installing using Server Manager, you may see the installation progress page remain open, but there is no error reported on screen, and the progress may not change for about 15 minutes. If you are using Windows PowerShell, the progress shown in the Windows PowerShell window will not change for more than 15 minutes. If you experience this problem, check the dcpromo.log file in the %systemroot% debug folder on the target server. The log file will typically indicate repeated failures to replicate. Some known causes for this problem are: networking problems prevent critical replication between the target server being promoted and the replication source domain controller. Because the installation process retries critical replication indefinitely, the domain controller installation proceeds if the underlying network problems are resolved. Investigate the networking problem using tools such as ipconfig, nslookup, and netmun as needed. Ensure connectivity exists between the domain controller you are promoting and the replication partner selected during the ADDS installation. Also, make sure name resolution is working. ADDS installation requirements for network connectivity and name resolution are validated during the prerequisite check before the installation begins. But some error conditions can arise in the time after prerequisite validation occurs and before the installation completes, such as if the replication partner becomes unavailable during installation. During replica domain controller installation, the local administrator account of the target server is specified for the installation credentials, and the password of the local administrator account matches the password of a domain admin account. In this case, you can complete the installation wizard and begin the installation before you encounter the access is denied failure. Enhanced install from media, IFM, options. Goal of IFM: deploy a DC more quickly. IFM prep and NTD SUTIL executed a mandatory offline defragmentation pass, creating a smaller DIT at the expense of time. In Windows Server 2012, NTD SUTIL's IFM prep is enhanced and now includes an option to eliminate the defragmentation pass, not the default, that remains as is. ADFS v2.1 in the box. ADFS v2.1 ships in the box as a server role with Windows Server 2012 integrated with Windows Server 2012 Dynamic Access Control. Virtualization-Safe Technology. How Server 2012 makes AD virtualization safe. From Sean Derby. We need to make a DC aware of when a rollback in time has happened. Second, the DC must take action that both preserves its integrity and allows it to function normally. To accomplish the first step, the layer that's executing the change, the hypervisor, needs to flag that a rollback in time has occurred and communicate it up through the virtualization stack. The application then has to recognize it. This process obviously requires that design changes be made to the hypervisor, the OS, and the AD application. The flagging mechanism is known as VM Generation ID. The VM Generation ID, or VM Gen ID, is a 128-bit value held in the hypervisor that represents the current generation of a VM state. As long as a VM continues to move forward in time uninterrupted, the VM Gen ID doesn't change. If the VM is rolled back in time, either from an image-based restore or from applying a snapshot, the ID is changed. This ID is mapped to an address in memory in the VM so that it's available to applications running in the VM at all times. How does a DC know if its VM Gen ID has changed? When a Server 2012 DC is initially promoted or upgraded, it stores the value of the VM Gen ID identifier in the MSDS Generation ID attribute on the DC's computer object in its copy of AD during PC installation. Whenever the DC reboots or processes a transaction, e.g. updating an attribute, it compares the current value of the VM Gen ID in memory with the value stored in AD. If they're different, the VM has rolled back in time and the DC must take certain measures to preserve integrity. The VM Gen ID is hypervisor independent, and other hypervisor manufacturers, as VMware, are building this capability into their products. If a VM rollback has been detected, the DC performs two actions to prevent USN rollback. It resets the AD's database's invocation ID and dumps its local relative identifier RID pool. Resetting the invocation ID, the version number of the local database, is the same action that is triggered if a normal restore process is run against the DC, and other mechanisms kick in to ensure that the DC has the latest updates from the other DCs it replicates with, including ones it created itself, but no longer has knowledge of due to the rollback. The RID pool is a collection of several hundred RIDs, part of the domain unique SID, allocated to the DC by the RID master to create SIDs when new security principles are created on the DC. Dumping the RID pool and requesting a new allocation from the RID master ensures that duplicate SIDs aren't created in the domain. Note that this doesn't get you out of regular backups, though. Rapid deployment, DC cloning. Steps for deploying a clone virtualized domain controller. Prerequisites. Step 1. Grant the source virtualized domain controller the permission to be cloned. Step 2. Run get ADDC cloning excluded application list cmdlet. Step 3. Run new ADDC clone config file. Step 4. Export and then import the virtual machine of the source domain controller. Demo, DC cloning. Requirements. I have started to prepare this from a Tom Moser's post. There are a few base infrastructure requirements to take advantage of DC cloning. The hypervisor must support VM Generation ID. Hyper-V running on Windows Server 2012 supports this feature. I have tried it with other last-generation hypervisors, and it works. The source virtual DC must be running Windows Server 2012. The piece DC emulator role holder must be online and available to the cloned DC and must be running Windows Server 2012. You cannot clone the PDC emulator. Clonable Domain Controllers Group. Membership in this group dictates whether a DC can or cannot be cloned. DCs shouldn't be added to the group until you plan to clone, and DCs should be removed from the group once cloning is complete. cloned DCs will also end up in the clonable domain controllers group. Make sure to remove those as well. The first step in the cloning process is to add the source DC to the clonable domain controllers group. Next, we need to create the config file dc-clone-config.xml. There's one key difference between a cloned DC and a DC that is being restored to a previous snapshot. dc-clone-config.xml. dc-clone-config.xml is an XML configuration file that contains all of the settings the cloned DC will take when it boots. This includes network settings, DNS, WINS, AD site name, new DC name, and more. This file can be generated in a few different ways. The new ADDC clone config cmdlet in PowerShell. By hand with an XML editor. By editing an existing config file, again with an XML editor. Notepad is not an XML editor. In my lab, I use the PowerShell cmdlet to generate the config. This is an easy, safe way to generate the file and ensures there won't be any issues during cloning. On your Windows Server 2012 domain controller, fire up PowerShell. Now that you've thoroughly reviewed the help page, let's go through the steps. On DC1, I ran the following. This cmdlet will generate a config XML using the specified parameters, in this case IP information, AD site to use, and that it's a static IP configuration. The IP information provided to this cmdlet will be used by the new cloned domain controller when it begins cloning. The cmdlet is going to do a few things prior to generating the configuration XML file. First, it's going to verify that the PDC is available and running Windows Server 2012 or later. Second, it's going to verify that the source, DC, where you're running cmdlet, is a member of the clonable domain controllers group. Finally, the cmdlet is going to check the DC for applications that may not support cloning. If any applications or services are detected, such as DHCP, generation of the config will fail. The cmdlet warning text is pretty helpful. It tells us that applications were found that are not on the allowed list. What's on the allowed list? Good question. You can find it at. This list exists by default on Windows Server 2012 domain controllers and should not be modified. If you want to add a discovered application to the list, you'll need to generate a custom DC allow list. Prior to generating the custom allow list, you'll want to review what applications actually caused the warning. Running get ADDC cloning excluded application list will show you that list. This cmdlet will dump out all of the services that were discovered while trying to generate the dc-clone-config.xml. From here, you can make the decision. Remove the discovered application or service, or add the application to the custom allow list. You've verified with the application vendor that the service is okay to clone. Generating the allow list is easy. Run get ADDC cloning excluded application list again, but specify the generate XML switch. The cmdlet generates the XML and writes it out too. See Windows NTDS. Once you've generated the XML file, you can run new ADDC clone config file again, and it'll successfully generate your config. Copying the source DC. The last step now is to export the source virtual machine. I have used VMware Workstation, so I cloned the domain controller. That's it. From here, it's just a matter of turning on the DC and letting everything happen on its own. cloning. I fire up the VM and had to wait the completing installation phase. A few minutes of this and the DC will reboot. When it's up, you should see a new DC in the domain controller's OU, and logging into the DC should indicate that you're in normal mode and not DSRM. This is the end of the first part. Thank you for your kind attention.